Let us do today the ionization of weak acid and bases. Ionization is a process in which neutral molecule it will split up into charged ions when it is exposed to solution. As you can see here, this is a weak acid which in presence of water it is splitting up into charged ions. So according to Arrhenius theory, acids, these are the compounds which dissociate in aqueous medium and they will generate what is known as the H plus ion, while the base it will generate OH negative ions. Now here let us consider the dissociation of a weak acid HA. So when it is dissociating, it is giving you hydronium ion and A negative ion. So let us apply the law of chemical equilibrium here, according to which K, that is the dissociation constant, that will be the product of concentration of products upon the reactants. So these are the products H2, so this I am writing in the numerator divided by the product of concentration of reactants, that is HA and water. Now we will arrange it in such a way that water it goes this side. So it will be K water is equal to, so it is K water is equal to hydronium ion A negative divided by HA concentration. Now K water I am replacing by another constant, that is Ka. That will be equal to the concentration of hydronium ion into the concentration of A negative upon the concentration of weak acid. So here the Ka is the ionization constant of acid, and it tells you about the relative strength. Larger the value of Ka, higher will be the concentration of hydronium ion and stronger will be the acid. Similarly, we can find out the dissociation constant or ionization constant of a base. So I am considering this example in which ammonia is reacting with H2O, giving you ammonium ions and OH negative ions. So dissociation constant will be given by product of concentration of products, that is ammonium ion, OH ions upon concentration of NH3 and concentration of water. Similarly, as we did it previously, K I will be water concentration I will be taking with K. So K and water concentration will become Kb. So Kb will be equal to concentration of ammonium ions, concentration of hydroxy ions upon concentration of ammonia. So this is the dissociation constant or ionization constant of a base. Let us do the calculation of degree of ionization. The hydronium ion concentration and degree of ionization, it can be calculated. Let us consider the ionization of a weak acid, acetic acid. As you can see in the equation, acetic acid reacting with water giving you hydronium ion and acetate ions. So Ka in this case will be H3O plus concentration and acetate ion concentration of and acetic acid concentration. Now let us suppose that C moles of acetic acid it is dissolved per liter of solution, and let us say that A be the degree of ionization of acetic acid. So at equilibrium, if you see, the concentration will be C1 minus A of acetic acid, concentration of acetate ions will be Ca. So Ka will be Ka, as you know, that is concentration of this hydronium ion CS3. So in terms of concentration we'll put that will be equal to Ca oblique. So that will be equal to Ca, that is the concentration of acetate, concentration of hydronium ion, upon C1 minus A, that is the concentration of acetic acid. So it will be C square A square upon C1 minus A. One C will get cancelled and you are left with Ca square upon 1 minus A. Since for weak acid A is very small as compared to 1, so A in the denominator it will be neglected, and finally the equation left is Ka is equal to Ca square. And knowing the value of Ka, you can calculate the degree of ionization of acid if the concentration is known. So alpha will be equal to root of Ka upon C. So from the degree of ionization you can find out the hydronium ion concentration, because hydronium ion concentration is nothing but Ca.